Good afternoon. I'm presenting my firefighting robot car. It's an autonomous firefighting robot built with ESP32 microcontroller. This was for our CC3116 microcontroller lab course project. So why this firefighting robot car? Bangladesh has faced tragic incidents where firefighters lose their lives during rescue operations. So, our idea was simple: reduce human risk by sending a robot first. This robot can detect early and extinguish it automatically before human even reach on the spot. So we made a small robot car that find the direction of fire using flame sensors and then spray water using a pump system, and that will be fully automatic. So this is the main components that we used: a ESP32 microcontroller, three flame sensors, a L298 and motor driver, four gear motors with wheels, LM2596 buck converter, relay module, water pump, and too many others that you are seeing on the screen. So, how it works? We connected three flame sensors left, middle, right to ESP32's analog pin GPIO 34, 35, and 32. We used analog signals because analog give more details about flame intensity and distance. So the ESP32 compares the three readings and decides is it far left, right, or straight. For movement, we used L298 and motor driver. We used two motors in parallel on each side, so it becomes a stable four-wheeler. ESP32 controls the driver using pin like ENA, ENB, and IN1 to IN4. So the robot can move forward, turn left, or turn right towards the flame. And this is the pins diagram, which pins are the reason for what kinds of works. So our battery is around 12 volt, but ESP32 needs 5 volt as input or 3.3 volt for operating. But if we use direct 12 volt, it would damage the board. So we use the LM2596 buck converter to step down 12 volt to stable 5 volt efficiently with less heat. The pump needs a high current at 12 volt, so ESP32 cannot drive it directly. So we used a safe chain from ESP32 to resistor to BC547 transistor to relay and to pump. The 1 kilo ohm resistor protects the transistor base current. The BC547 works like a switch or amplifier, and the relay provides a electrical isolation to the control the 12 volt pump safely. And this is the connections that we have used for our BC547 to relay and ESP32. And this is the role of their which we have written that they are which we have used that. Now, why we use servo? We added a servo so that nozzle can aim precisely. The servo rotates based on flame detection and we control it with PWM on GPIO 33. So instead of spraying randomly, it sprays exactly towards the fire, and these are the connections for the servo motor. And finally, this is the working and flow diagram. For the project, the overall flow is mainly buck converter powers ESP32, sensors send readings, ESP32 detects fire direction, robot moves towards flame, servo aims nozzle, relay turns pump on, water sprays automatically. All grounds are common to the signals table. And these are the mainly challenges that we have faced. If I mention, we faced real hardware issues like voltage drop when motors and the pump runs together, noise in analog sensors, sensor fluctuation from heat light, and servos jitter due to sudden current drop. We fixed this with better grounding, turning threshold, adding proper timing delays and correct action sequencing. Move first, aim, then pump. So this is the conclusion. We successfully built an ESP32 based firefighter robot car. The buck converter ensures safe, stable power, flame sensors enable early detection, servo gave accurate aiming, and transistor relay control allowed safe pump operation. This is a low cost that can reduce human risk in fire emergencies. And that's can we improve it further, like that in future we want to add a camera plus AI detection, thermal sensor, higher water pressure, GSM and Wi-Fi alerts, and a stronger industrial chassis for a better precision. So that's all. Thank you. I will add the demo video after the presentation slide.